our derivative rules. And so today is derivative rules day 2. And so today will be topics out of 2.4 and 2.5. Now, the very last one we looked at was the quotient rule, and that was rule number 8. And so this one will continue with number 9. And number 9 is the 4 other trig functions. All right, so we have sine, derivative of sine is cosine. We know cosine, the derivative of cosine is negative sine. So our next trig function is tangent. So if f of x is equal to tangent x, then we'd like to know what our derivative is going to be. All right, now to fill in the right-hand side of this equation, we're actually going to figure out what the derivative of tangent should be. So let's start out by writing down our function. F of x is equal to tangent of x. And we'd like to find the derivative of tangent of x. And we have no idea at this point, unless you open up your book and you look. We have no idea what the derivative of tangent of x is equal to. But we do know something about tangent x. What do we know about tangent x? What is it? Yeah, it looks like sine of x over cosine of x. So we can rewrite our function as f of x is equal to sine of x over cosine of x. And this one's a lot better because we know derivative of sine, we know derivative of cosine. And the way this is written, we've got sine of x divided by cosine of x. So we're going to be applying the quotient rule in this thing. So our derivative is going to look like, here's the quotient rule up here. Our derivative will be low, cosine x, times the derivative of sine x, minus high, sine x, times the derivative of the low, which is cosine x. Draw the line and square below. So we have cosine of x squared. All right. Any questions on what we've written down there? Our goal is to write down what our formula for the derivative of tangent x will be. Okay, so let's start to write some things down here. Cosine x. Derivative of sine x is cosine of x minus sine x. Derivative of cosine of x is negative sine of x. Draw the line. And on the bottom, we have cosine squared x. All right, so looking at what I have here, I've got cosine x times cosine x, so that's cosine squared x. And we have two negatives, which makes a positive, so we have plus sine squared x divided by cosine squared x. Anybody recognize something about this numerator?
Is that equal to 1 squared? It's the, what you call it,
Yeah, so first of all, this numerator, cosine squared x plus sine squared x, is the Pythagorean identity. It says that cosine squared x plus sine squared x is equal to 1. This is the #1 coolest, most useful trig identity you will ever write down. And so if you don't have it tattooed yet on your body, you might want to consider doing that. All right, so cosine squared x plus sine squared x is equal to 1, best trig identity ever. All right, so what is that going to do for us? Well, that tells us that f prime of x is equal to 1 over cosine squared x. And what do we know about 1 over cosine x? Yeah, that's the same as secant x. And so 1 over cosine squared x will be secant squared x. right, so what we've just shown is that the derivative of tangent x is secant squared x. And so another way that we might write this is that the derivative, d over dx, of tangent x is equal to secant squared x. So if you ever get to a test and you forget what the derivative of tangent x is, you can always derive that formula by doing this. You can always use the quotient rule, write tangent as sine over cosine, and use your quotient rule, and you'll get the same derivative in the end. All right, so that takes care of tangent. Any questions about tangent? Good. Our next one is secant. And so if f of x is equal to secant of x, then we'd like to know what our derivative is going to be. So we're going to start this in the same way. We're going to start out with f of x is equal to secant x. And you guys already told me that 1 over cosine x is equal to secant x, so secant x must be the same as 1 over cosine x. So let's rewrite that. F of x is equal to 1 over cosine of x. So now what we have is we have a ratio, we have a quotient here. So we can use our quotient rule on 1 over cosine x. 1 is our high, cosine of x is our low. So our derivative, f prime of x, looks like low cosine x times the derivative of the top, the derivative of 1, minus high, which is 1, times the derivative of the bottom, so d over dx of cosine x. Low d high minus high d low, draw the line, and square below. All right, so our f prime of x looks like cosine x. What's the derivative of 1? 0, yeah. Minus 1 times the derivative of cosine is negative sine x, all over cosine squared x. Okay, so this first term, 0 times cosine x, that's 0. And our negatives cancel, and so we're left with sine x over cosine squared x. All right, so this is a legitimate final answer. But I'm actually going to rewrite this in one more way. It's going to make it look nice and pretty. I'm going to rewrite this as sine x over cosine x times 1 over cosine x. If I multiply across the top and across the bottom, I get back sine x over cosine squared x. And so if I write it in this way, sine x over cosine x, what's that one? Yeah, that's tangent x. And 1 over cosine x is secant x. And so what that tells us is, if f of x is equal to secant x, then the derivative of secant x is tangent x, secant x. All right, so, yes?
Sorry, sine x over cosine squared x was our original value that we calculated, right?
Yes.
What if we put 1 minus sine squared x instead of cosine?
On the bottom here?
Yes.
Sure, we could also write this as sine of x over 1 minus sine squared x. That's using the Pythagorean identity up there. And so that would also be a legitimate derivative as well. This is kind of the standard one that most people go by, but absolutely this is just as legitimate. Okay, so I'd like you to say hi to your neighbor. Hi to neighbor, anywhere around you. And I'd like you to share these two derivatives along with the derivative of sine and derivative of cosine with your neighbor. You have 10 seconds.